Today we're talking about how to create and graph quadratic equations using just the x-intercepts. We've been working for a long time now with quadratics. Quadratic equations like f of x equals 3x squared minus 15x plus 12. And of course that equation's in what we call standard form. We've also been learning how to factor quadratics. I can look at this equation and see that I have a greatest common factor of 3, so I'm going to divide all 3 terms by 3 and bring that 3 out front. And then I'm going to take the trinomial that's left over and factor it into x minus 4 times x minus 1. When I have it completely factored, this is what we call factored form. It has another name though. It can also be called intercept form. It's called intercept form because when I set f of x equal to 0, I can use those two factors to help me find my roots or x-intercepts for this function. So what we did before was we had our equation equal to 0, and then we took each factor and set the factor itself equal to 0. So x minus 4 when it's equal to 0 gives me x equals 4. X minus 1 when I set it equal to 0 I get x equals 1. So 4 and 1 are my two solutions, also known as roots, also known as x-intercepts for this particular equation. So if I wanted to write them as x-intercepts, I would write them as points. I would write them as 4, 0 and 1, 0. But for now, I'm going to focus on just those two values. I want you to take a look at those two values and look at where those particular numbers can be found in factored form. 4 comes from my first factor, right? It's being subtracted from x. And 1 comes from my second factor, which is also being subtracted from x. So let's take that and write it in general terms. This is the official format for factored form. F of x, remember it doesn't always have to be f of x. We can have g of x, h of t, whatever we need this to be, equals a times x minus p in parentheses times x minus q in parentheses. Now in factored form, p and q are going to be our zeros, otherwise known as roots or solutions or x-intercepts, right? They have a lot of names. So p0 and q0 are my x-intercepts. I want you to take notice that p and q are both being subtracted from x. We're going to need to watch our signs in our factored forms to make sure that these two numbers are what's being subtracted from our x's. So let's hurry and take a look at this parabola, right? You guys have graphed parabolas an awful lot by now. You know all the parts. And thanks to factoring, we can find the x-intercepts easy enough. But from factored form, we also need to be able to find the vertex, the axis of symmetry, and the y-intercept. Let's take a look. If you're looking at these two x-intercepts, I have an intercept at -1 and a y-intercept at +3. Where is the axis of symmetry in relation to those 2 points? It just happens to be halfway in between our two x-intercepts. Now in math, it's really easy to find a value that's halfway in between two numbers. We simply use average. So I can take my two x-intercepts, -1 and +3, and I can find their average to locate my axis of symmetry. So I'm going to add my two x-intercepts together and then divide that value by 2. And my line of symmetry or axis of symmetry is at x equals 1. So then we're going to kind of treat this equation like we would if we had an equation in standard form. We're going to substitute that axis of symmetry value for x in our equation to help us find the y value of our vertex. We're going to take care of that in our example. We're not going to do it here because we don't know what the formula is for this graph. Our y-intercepts can be found just like we do with any other equation as well when we substitute 0 in for x. That's going to help us find our y-intercept. Remember, we're not going to have a c this time. We've got to do it using factored form. Okay, so let's take a look. Here's our first example. We have f of x equals negative, remember that really means -1, times x plus 6 times x plus 2. We need to find the x-intercepts, the axis of symmetry, the vertex, and the y-intercept. Okay, and then we're going to take all that information and put it on a graph. So, remember how p and q were being subtracted from x? And also remember how subtracting a negative is the same as addition? So if I need to, I can actually rewrite these two factors so that I have subtraction. So I'm going to go ahead and write that -1 out front because it's going to come in handy in just a little bit. X plus 6 is the same as x subtracting a -6. And x plus 2 is the same as x subtracting a -2. Why would I do that? Because in intercept form, my p and q values are being subtracted from x. So to be able to identify p and q, I need to have them in subtraction mode. So now I can see that p is -6 and q is -2. And I'm going to take those values and write them as points to identify my x-intercepts. So -6, 0 and -2, 0 are my x-intercepts. -6 is p, -2 is q. It's not going to really matter which one's which. Now I can find their average to identify my axis of symmetry. So to find the average of -6 and -2, I add them together. That gives me -8. Divide by 2, I get -4. So my axis of symmetry is at x equals -4. Now I'm going to plug that axis of symmetry value in for x to help me find the y value of my vertex. So I'm going to take that -4, plug it in everywhere I had an x before, and now of course I'm going to do what's in the parentheses first. So I have this -1 out front. It's going to stay the same. -4 plus 6 is 2. -4 plus 2 is -2. When I multiply -1 times 2 times -2, that gives me a +4. So my y value of my vertex is a +4. So -4 that I plugged in and the +4 that I got out gives me my vertex. Now to find the y-intercept, we substitute 0 in for x. 0 plus 6 is 6. 0 plus 2 is 2. -1 times 6 times 2 is -12. And that's where my y-intercept is going to be, at 0, -12. So let's look at the instructions. Did we find everything? Did we find x-intercepts, axis of symmetry, vertex, and y-intercept? If so, we're ready to go to our graphing stage. So I'm going to write down everything that we found so far. And now we're going to put it on a graph. We're going to start with the axis of symmetry. That's a good place to start. Oh wait, I started with the x-intercepts. Sorry about that. X-intercepts are at -6, 0 and -2, 0. Our axis of symmetry is halfway in between at x equals -4. I'm going to put the vertex on that line at -4, 4. And my y-intercept at 0, -12, which is a little bit off my graph. That's okay. Remember, we can reflect that y-intercept across your axis of symmetry to give us yet another point to help us graph. And that gives me a pretty good indication of where that parabola is going to be. Notice that it opens down. My maximum value is at 4, right? I can find all kinds of information now. Let's go through one more example. This one's just going to be a little different. We're going to start with a graph and use the intercepts and a point on the graph to write our equation in standard form. I know that we're working with factored form or intercept form today, but we're going to actually use intercept form to help us find the standard form. So remember, we've got our two x-intercepts, -1 and +4. We're going to make one of those P and one of those Q. And to help us out, remember it says use the intercepts and a point on the graph. Well, I'm going to pick a random point on the graph. I'm going to pick 3, 4, just, I don't know why, just because it's on the grid and it's a nice point. And I'm going to let those values help me write my equation. So let's look at how this works. My y-intercepts were at 4, 0 and -1, 0. In other words, P, I'm going to say P is 4 and Q is -1. And my random point is 3, 4, and I'm going to make that x and y. So I have a lot of information that I can substitute into this intercept form, right? First of all, I can take P and Q and put them in their places. Then I can take x and y and put them in their places. The reason I had this line in between is because the double negative here became a positive. Then I can take 3 and put it everywhere I had an x, and 4 and put it where I had a y. Now I'm going to do a little bit of simplifying. In my parentheses, 3 minus 4 gives me a -1, and 3 plus 1 gives me a 4. A times -1 times 4 gives me -4a. And when I divide both sides by -4, I get a is -1. So now I have a value for P, a value for Q, a value for A, and those three values are going to help me find standard form. First, I'm going to plug those values into intercept form because that's what we're working with today. Next, I'm going to take the time to multiply those two factors back together. Remember, when I multiply them, I have to distribute the x and distribute the -4. So I get x squared plus 1x minus 4x minus 4. I can combine like terms to get x squared minus 3x minus 4. Then I have to take care of this -1 out front, and all I'm going to do is distribute it through the parentheses. So I end up with f of x equals -x squared plus 3x plus 4. And voila, we're in standard form. I I think that's plenty for today. Make sure you write down any questions that you have so you can remember to ask them in class. I hope you're having a great day, and I'll see you next time.